we're just about to found and open in China. What we do is thermal energy storage in simple words, and in simple pictures, it stands for a big box that stores high-grade heat. Yeah. And the interesting thing about, at least what we think about our technology, is that it has only very few components, 5 so to say. Yeah. The 2 largest components are steel, regular carbon steel, and a high-performance concrete. Other components include some installation, cladding, piping, and sensors, a lot of sensors, but I guess we talk about digitalization later on. Where it plays a role is the energy market. And for us, in our little world, the energy market is divided into 3 segments. First of all, not so relevant for here, for this neighborhood, is concentrated solar power, so solar thermal applications. But there's a lot of places where you have a lot of sun and where it makes complete sense. Second, and very interesting segment here for Europe and also the US is industrial applications. So what we do in simple words is we take waste energy, so energy that's currently going up the chimneys in large industrials and not being used, and we park it until it's being used. So for instance, we take excess energy from one smelter, park it for a couple hours, and then introduce it into another industrial smelter when actually energy is needed. And currently the industrial would use natural gas, for instance, to generate that heat. He doesn't have to do this anymore because now he can work with energy storage. The third segment we are focusing on is the power grid. And here we offer really, really large-scale gigawatt-hour energy storage for the power grid, especially to help the transition from conventional thermally generated energy into fully renewables. It's a long journey, I think we all agree, and here we can help with a very cost-efficient solution on bulk energy storage. Now, Antonia was mentioning the concept of circular economy, and I think if you take a step back, the interesting thing is that Energy Nest perhaps stands for new generation of developed products or even companies that pays into the circular economy accounts. And I would like to give 3 examples for this. One is that from the nature of what we do, the DNA of our thought, of our value add, is to take a product that is generated in excess, in our case thermal energy, and is being needed when it's not available. So we provide energy storage from something that is basically available at access time but not available on demand times. That's the first example. The second example is that for Energy Nest, we do not work with any sort of big factories, manufacturing footprints or gigafactories. It's rather about building global manufacturing partnerships where we can access steel manufacturers or concrete manufacturers. Let's not forget the steel. There's big steel producing countries out there that offer standard steel products. China, Vietnam, Romania, US, the Baltic states, you name it. For our concrete, for example, interesting perhaps that 75% of our high performance concrete can be sourced locally in local quartz pits. Again, you name it, in different countries. Quartz is highly or widely accessible. 25% though we do not disclose because it's sort of a trade secret. So that's basically paying into the account for the global manufacturing networks that we can work with and that we do work with. And the third example is, I think, every product has a lifetime and a certain life cycle. So in case our energy storage one day, many years down the road is not needed anymore, you can recycle it. And for the 2 main ingredients, again, concrete and steel means, the concrete you can dispose by just converting it to gravel and using it for roadworks, for example. And the steel can be reused by smelting it again and making it accessible for new steel products.
Thank you very much. And so I'm a thermodynamics geek at heart. And so you are taking heat that would otherwise essentially be vented and wasted. Oh. And then would have to be replaced later in the cycle. You'd have to then probably use natural gas or coal to recreate that heat in your industrial process, exactly, yes. Right? So there's probably people in the room who've got processes that are doing just that, and you'd be very interested, no doubt, to talk to
Absolutely,
them.
Yes.
I'm very intrigued, as I say, I'm a thermo geek, but the traditional use for that vented heat would be to say, well, let's use it in CHP, let's try and use it to heat, a local, housing estate or possibly to even air condition through a heat pump to air condition a sort of local community. Why is yours a better solution than that?
Well, I think if you look at the thermodynamics of our product, if you have a piped solution in the storage in between, the thermal efficiency from heat in and heat out is about 95% at least. So the bigger the storage, obviously, the higher the efficiency. I think another interesting fact is once you have your system charged, the heat loss per 24 hours is 1%, which I think makes it quite efficient, also driven by the simplicity. And then, of course, the overall thermodynamic impact in a setting depends on the setting of the industrial, so what he's using for. But I give you one example of a project that we are just discussing here with customers in Germany, actually, is the beauty of the, let's say, vast application space. Because you take from one process surplus heat, you park it, and you introduce the heat into another process. Now, and this refers to a heat source where the heat is coming from and a heat sink. In that case, the heat sink does not need all of the heat that's generated by the heat source. So the customer very much wants to install a small turbine, organic Rankine cycle, to convert basically from waste heat his own electricity. So he needs less brown energy off the grid. And lastly, this organic Rankine cycle also has a byproduct of lower grade heat, which goes into the district heating system of that very city. And that's interesting because there's very interesting tariffs in place, because district heating is needed, hot showers, heating, etc. And there's, I mean, in Northern Europe, we look at large district heating networks. In the US, it's less so, but in China, I think it's also very big. So this just gives an interesting idea that you can, with such technology, also play with and enhance an energy efficiency system.
And the temperature heat that you need as an input is what?
Well, I think it shouldn't be less than 250 degrees Celsius. And currently, our upper limit is 400 to 450 degrees Celsius to store. But of course, we can also capture energy that's at 700, 800 and just dilute the heat a bit, obviously.
Okay, very interesting. So I hope you've got some spare heat at medium-high temperatures there. Our final panelist I'd like to bring in is Amelie Wolf, who's executive on strategy and growth initiatives at GE. And of course, GE being GE, you're probably doing some of all of the things that we've heard about here so far.
Yeah, indeed, you're well pointed out. Welcome. Thanks for having me. Thanks for having us here on the panel. Indeed, GE is a broad company, as you know. I think if you look at the portfolio today, we've got, and maybe some consider that good, some consider that maybe bad. We've got the whole chunk of power generation sources in the portfolio. So you talk steam, you talk oil and gas, you talk about renewable energy, where I sit, and some of the observations that we see and some of the demands we're getting from our customers clearly go more towards the direction of using green energy and buying green energy hours rather than being the old gray manufacturing company or industrial company that's still procuring and using coal in that regard. Where we place, we are on the renewable energy side of things. We're in the wind space, so we're battling with Felix on every wind turbine. We're in the solar space, both on the PV side as well as concentrated solar, as Christian mentioned. We are also in the steam business, which is not so much renewable, you think, but more in the conjunction of concentrated solar power and how we make that work, and also the thermal storage power in itself. And last but not least, we're involved in hydro. So a big chunk of hydropower generation that's out there in the world is from GE, or previously known as Alstom equipment and machines. Now, I think what we are hearing is everyone loves renewable energy. It's green, it's clean, it's nowadays cost competitive with both conventional and fossil fuel generation. I think the one issue that we always get, or the one complaint that we typically hear, is that it's not reliable, right? So you've mentioned the word intermittency. It's almost it's a forbidden word in our company. But you've got variable generation sources which may not be available when and if you need them. So along with all of the panelists before, we strongly see a big growth opportunity, a big need, in fact, for an enabling technology, and we believe storage is such. So, whether that's thermal storage for long-term, large-scale storage, or whether that's battery storage, or maybe even pumped storage as an alternative, to be decided, and I guess subject to what the location is and where we're talking about. But clearly for us, and I think maybe for some of the people in the audience, how to make that green energy reliable so it in fact replaces baseload generation from non-green generation sources is a question that we deal with day to day. And as such, as I said before, storage is a key enabler on that regard.
Okay, and we'll come back to some of these opportunities in more detail, but I want to ask you about something else that GE is very much there's a couple of areas where GE is a huge pioneer. One we've already mentioned, which is digitization, but let's come back to that one as well. And perhaps you could talk about future manufacturing technologies. I mean, we hear a lot about additive manufacturing, 3D printing, also some very advanced materials, graphene and goodness knows what. How real are they currently? Because my assumption is that if anybody's going to use them early on in the process, actually use them for real, that would be a company like GE. Well, it's either GE or it's going to be some sort of some startups. So is that real? Should this audience already be thinking, okay, that's going to happen and we need to factor it in? Or is that really something that you'll be talking about for the next 20 years, but we won't see actually concretely happening?
So I can tell you in GE ourselves, we already use additive manufacturing. Where we use it and where still today I think makes most sense is when you talk about components. So I don't see a reality yet in using a 3D printer to print a blade. It's just not happening, right?
A blade, I mean, that's
blade.
60 meters long, right?
Exactly. So I don't think that that'll happen anytime soon, but we had our opinions about storage and it happened quicker than expected. We had our